Okay, this time we're going to talk about rational equation forms that lead to quadratics. And of course, in this case, a quadratic equation is going to result when we multiply through. Remember, when we're solving a rational equation, our job was to multiply through by the least common denominator of all of the fractions. And this is going to clear out the fractions when we distribute and give us a way to solve for x. So let's do this. We have denominators x and 2x plus 1, and of course 1, if we think about 2 as 2 over 1. So our least common denominator in this case is going to be the expression x times the quantity 2x plus 1. So that's what we're going to multiply on both sides of the equation in order to clear out our fractions. So we would take x times 2x plus 1, multiply it by 2 over x. We're going to take x times 2x plus 1, multiply it by 3 over 2x plus 1. Now, if it helps you to visualize what's going on right here, the quantity x times 2x plus 1 is itself over 1. Right, so you can continue to visualize it that way. We're going to get x times 2x plus 1 over 1 times 2. And so now what's going to happen? Well, our denominators are going to cancel out. So we're going to get x canceling here, leaving us with 2 times the quantity 2x plus 1. 2x plus 1 will cancel with 2x plus 1 in this denominator, leaving us with minus 3x. And on the right-hand side, we're going to end up with 2 times x times 2x plus 1. And because when we multiply through and use our distributive property, we're going to end up with a quadratic equation. On the left-hand side, we get 4x plus 2 minus 3x, and on the right-hand side, we end up with 4x squared plus 2x. We need to set this equal to 0. If I take 4x and take away 3x, that's x plus 2 is equal to 4x squared plus 2x. So I'm going to subtract x from both the left and the right. I'm going to subtract 2 from both the left and the right. And I'm going to end up with the equation 0 is equal to 4x squared plus x minus 2. So we need to find our factorization of 4x squared plus x minus 2 in order to solve this one. Well, is that possible? Let's see. If we were to solve this one, we would have to be able to, if we could solve it by factoring at all, we would have to be able to try and find the solution by using our factorization method. We need to be able to find factors of 4x and 2x whose sum is 1. If we were to go through and check this out, we do have a test, right? Is it factorable? Well, b squared minus 4ac would have to be a positive perfect square for that to happen. B squared is equal to 1 minus 4 times our leading coefficient is 4, and our constant term at the end is negative 2. So we would have to be taking 1 plus 4 times 4, 16 times 2 is 32. That's going to give us 33. And because it's not a perfect square, this is not factorable. But even though it's not factorable, we've already done part of the work that we need to do, because we could use our quadratic formula wherein a is equal to 4, b is equal to 1, and c is equal to negative 2. And if we make that substitution into our formula, we're going to find that x is equal to negative 1 plus or minus the square root of b squared minus 4ac. Well, we've already done that, right? We know what 1 squared minus 4 times negative 2 is equal to. All of that is going to be divided by 2 times 4. So it's equivalent to writing x is equal to -1 plus or minus the square root of 33 all over 8. And so our solution right here turns out to be a radical. I will tell you right off the bat that it does not produce a 0 in the denominator, and to check this solution is going to be a little bit time consuming. So I'm going to leave that as an exercise, but I will tell you that it does work, and so x equals -1 plus or minus square root of 33 over 8 is a kind of solution that we can have even to a rational equation. All right, one more example.